Hi, today's video is about a DSO-SHELL kit from JYE Tech or made by JYE Tech. I bought it from Banggood and this is the third video already with this neat little device. It is a digital storage oscilloscope. Yeah, it's more like a toy, but it's fun to build it. The second video I already modified it with a battery and I just throw it together, not very carefully, and with a lot of hot glue and two big components, so it works, but it was not so beautiful, so schön. And some people mentioned, oh, show me some links with smaller DC-DC converters, and so yeah, I make a new one. This time I put more effort in it. Also so much effort that I decided to make some LEDs, one LED there, one there, one there. This LED is for trigger, this is for charge, and this is for charging. The battery I put in about now is over 1000 milliampere hours. It's an older one. I think new it could have a size about 1800 milliampere hours, but with 1000 I'm already very happy. And to charge it, you don't need the micro USB connector. I used the standard plug it comes with on the board. So no extra holes needed. Just plug this in and you can see it still works. You can still use it and the charging LED goes on and it draws about 710 milliamp. Yeah, that's all for the introduction. The video will have about 6 parts. The first part is about the main board, then is the battery, then is the front panel, then is the assembly, testing, and at least a giveaway. Yes, you will get a giveaway, but this I will show you at the end of the video. Okay, how to get started. First part we modify is the digital board with the display and the power connector and the switch. I want to use the power connector as a charging port, and I wanted to use the switch to switch on and off the DC-DC converter. So we have to modify it a little bit, because these things are not built to do it what I want to do with it. So the first two wires, the first red wires here and here, are going to the switch, underneath the switch. And to do this, I have to cut the two traces going up to the rest of the circuit here. So, and to show you what I done, I sacrificed the board for you. Not really sacrificed for you, it's just burn while the process. So, goodbye, one has left us. But so I'm able to show you which traces I cut. You see here a little bit messy. I was trying how the best way, doesn't matter, and also scrap a little bit to follow the traces. It's not easy to see with the blue solar mask, solar paint, where the traces go. The second two wires, the black and the red one, plus and minus, are for the it's VCC, it's for the board, it's to power the board really on. And because I removed the switch, I have to find another place to power it, and the best place I found is the this pin from R30, the R30 close to C10. I removed R30, the 0 ohm resistor, and yeah, soldered on this place. This is plus 9 volt coming from the DC-DC converter, and the ground is just on the main ground here. I think that should work. Because it was not easy to follow the traces, I also removed the polarity protection diode, D2. It was here because I have to use, or I wanted to use the power port or the power connector here to charge it. So I have to get out the wire from here and bring it to the board. And the ground for it is the same. It is the same ground, just going here. So I have 6 wires coming out. The first 2 for the switch, the number 3 and 4 for the powering up the digital board, and the digital board powering up the analog board. And the last 2 wires are for charging. So these two wires, it's the right one, goes to the battery, charger and protection board. So that's done. Another modification is about here. Normally you have a diode here, an LED, and this is showing you the trigger pulses. I wanted to have it on the front, so I removed this LED and make something on the front. You will see the next part. Last modification, now I'm not sure if I really need it because I have plenty of space now left, is the rotary encoder. It normally, or the standard, has a little board. It is mounted on a little board and then screwed into the front. I thought I can make it smaller, and so I didn't use the board. I just bent the legs to the other side and soldered in. When you do this, make sure that you have no shortcut between the case here and some of the connections. If I remember right, this pin and the middle one need to have, or will be connected to the case because it's ground. So don't worry if it beep here and here, or was it here? One of them can beep, not the other, okay? And yeah, that's all for the digital board. Very easy, was done in short time. Expect that I have to do some research and sacrifice one of it. Okay, just sacrifice, doesn't matter. Okay, this board is finished. The second part I have to build is the battery, or the DC-DC converter, step-up converter, whatever. You can choose your own design. I have this. I come up with this because this was the size of my battery. I didn't buy it. It was some device I taken part. I'm not sure. It's not the best battery. It holds about 800 to 900 milliamp charge. I can even get a smaller one with the same capacity, but I have this now, and yeah, it works. That is the most important thing. Here you see the battery protection and charging board. It is connected to the battery, and the ground is already connected to the DC-DC step-up converter. And this is very small one, but even capable of driving 2 amps. That is a lot. I already set it up to 9 volt, a little bit less than 9, so it is safe to operate the DSO-150. And I already removed the 2 LEDs on the battery protection and charging board because I wanted to have the charging LED and is charged LED on my front panel. I don't want it to have it inside. It's boring. It has to be on the front panel. Yes, that's done with the battery. You just choose whatever battery you have and how much place you have, but these components are very easy to handle, so don't worry about it. The last part that we need to modify is the front panel. Unluckily, or just was not careful enough, I make some scratches in the front. That is really sad because the rest comes out very well. I put in, or I built in, no, I throw it in, 3 LEDs. One here underneath the trigger, one here beside the JYE Tech symbol, and one here in front of DSO-SHELL. Unfortunately, I just threw it in the D, but they're how to say, stickers, not stickers, the paint is really not well laid out here, but it was impossible to remove it without making it more worse. I tried at the I call it now the testing board. You see I make some tests here, and I try to remove the paint. It changed the color of everything, so I keep it like this and have the scratches. Yeah, too bad the scratches. Yeah, what kind of LEDs I used? I used standard SMD LEDs. And to get the light through, or to see something on the front, I drill a very small hole in it. Was using a 1.5 millimeter drill to drill a very small hole. On the other side, on the side where we see the LED, I have an about 3mm drill and drill another little bit, not to say curve in it. And then I fill the hole with hot glue. So after filling with hot glue, it is flat on the surface. Maybe you can see there's no hole anymore. This is just flat, and the hot glue also, how to say, smoothen out the light, or just make it more even, the light. No, it doesn't point out a small dot. It's more like a diffusion. Okay, so I think this is the best idea to put in the LEDs on the back. They are held with some hot glue and with some Cyanacrylate or Blitzkleber, called in Germany. We call it Blitzkleber because it's very fast. Usually when it's not old and laying around. I waited for about 2 hours before it was settled up. Yeah, doesn't matter. At the end it works. Also, these cables have already almost the right length because I put it together already and tested it before I make the video. So these cables are already in the correct length. If you do it, I always think it's better you keep the cables long and put it together and try, and at the end you cut it to the final size. Yes, that is the third part you need, the front panel. Of course, you don't need to make it, it's just if you want, but I think LEDs in the front is the best. So now, after I show you all the parts we need, it's time to put it together. I will start with the front page. Did I say front page? I mean with the front. The front, the face plate and the main board. Just put together like this. It's not the official way, I think, but it fits well. I still keep the protective film, or no, this should be the final assembly. Time to remove the protective film. Yes, you see, now it's removed. Looks nicer. Just put it down, keep it like this, and then soldering the wires for the LED. Just need to concentrate for a second. Wait before I talk again. It's not the most place here. Yoo-hoo, it's done. This step number 1. Connecting the trigger LED to the front panel. So, turn it around. Bring in the bottom case and the analog board. So, analog board, just place it there. Got the 4 screws. Of course, with my new wiha XIAOMI screwdriver kit. I really like it. Show one more of my co-workers and have to order one more because they also want it. Yeah, quality compared with the price is really good, and I totally like the design. It's a really great design, and so I want it. Yeah, of course I forget this. Yes, this could happen. I almost broke my camera setup. Okay, so before you place the analog board, you have to mount the back plate on it. Just put it on there like this and then turn it around, and then just insert on the place. And using the XIAOMI wiha screwdriver kit, I really like it. I already ordered one more for another co-worker, also see it and want it. So this is really a great tool, feels very good. So this part is also done. No, not really, because now we need the battery, and this can become later. The battery, I really have the perfect size, just fits here. And to keep it on place, keep it at place, in place, I just using a piece of double-sided tape. If I find my double-sided tape, just give me a second to search for the double-sided tape. Yeah, who throw it there? Because I'm the only one in this room. I guess it was myself. So, have the double-sided tape. Very, very sticky one. So I'll only stick one in the back. Just there. Press it in place. Don't worry, it will hold. This time I won't use any hot glue. No, in the front I already use hot glue. So, time I bring in the front assembly. And maybe already this. Oh. This goes there. So what to do here is to soldering the different wires on the place. First I start with the LEDs. I marked the cables a little bit, so I should be able to see which cable goes where. It's really not easy, just bring it in a little bit. I tried to mark the cables because this have no color. I'm not sure if it was very successful. So these are the 4 wires to the LEDs in the front to show if it is charging or not, or if it is already charged. These 2 going to the input of the battery protection charge board, coming from the the plug, the round plug in the middle, in the front. So also not so critical. I need to make sure that I don't mix the polarity. Yes, plus and minus. You know what I want to say. So then these 2 are going to the output of the DC-DC converter. It's there. Minus is there. This one goes to the output of my battery protection charger board, and this one goes to the input of the DC-DC converter. So everything in place already. First try can be like this. The light should come on. Yes, and I already connected the red LED on the right way. You can already see it a little bit. Time to switch it off. Now it's a little bit figurey, not so easy. Just need to put this like this. I think it's better to get this out first. And now it's time to press in the cables. So, all cables are in place, not on place. I think in place. Time for the rotary encoder knob. For this. Oh, I think I mix it up. Oh, should be like this. Yes, just press it together. Get 4 screws. 4 screws for the back. The plastic they use is not the best, to be honest. If you remove the screws 1 or 2 times, you really have difficult to tighten it again. But it's okay. So I explain you all the parts I built for it. I show you how to assemble, and it's come together well. We already see the trigger LED work, and now we need to see if the charging LED is working. To check this, I bring in a power bank, doesn't matter, something, USB charger, and an USB cable to the round port I'm using for charging. So I plug this here. The other end goes to the power bank in my case, switching it on. And the green LED should come on here to show you that it charges. And at the moment I'm drawing about 770 milliamp because I think the cable is not so good. Now time to power it on. You see I can charge and power it on the same time. Doesn't matter, it's still charged, or then it used the power from the power bank and it still works. So I'm generating a signal with the Aneng AN8008 because it's easy and fast, and I start with a 50 Hz signal. The input is still on ground, and here we see we have a 50 Hz signal. I can go up with the signal to 100, 200, 300, 400, 500, and you see the trigger LED is working fine. As promised at the beginning of the video, this is part number 6. The part with the giveaway. And what do I give away? Yes, of course, one kit of the DSO-SHELL. Yeah, this is, I open it, I don't know why, there's so many. It's a complete kit from the DSO-150. So that is part number 1, but I will give you more. There will also the DC-DC converter step up and the battery charging and protection board I used in my project. Then you need some kinds of wires, the very thin one, the normal red and black one, and I provide white. I didn't use another color for the switch, but I recommend that you use this. Then going ahead with those things, some solder. Yeah, you will need solder, so I give it to you. Then you will need the small SMD LEDs. Unfortunately, I only have one color left. Yeah, that was the rest I have. But if you're good, you can reuse the LEDs you desolder from the boards. Then I give you the 1mm and the 2mm drill, 1.5 and 2.5mm drill to make the LEDs in the front panel. Then you get the USB connector and the cable with the barrel plug. So you should be able to build the whole DSO 150. Only part I doesn't provide to you is the lithium-ion battery, because it's not safe to send them. Sometimes it's not allowed to send them, and to be honest, I don't have any more in this size, so I cannot send you. But this you will get. Only thing you have to do is write a comment. Then at the end of November I will draw a winner. I think it will be about the 20th of November will be the drawing, using some digital things to see who will win the whole something. Okay,